So this video is an optional one, extra example. The position of a particle is given by s of t equals t cubed minus 6t squared plus 9t. So if we want to know where a particle is located at any given second, we're going to plug it in right here into s of t. So A is asking that. Actually, I'm sorry, A is not asking that. A is asking for the velocity. So guess what? Remember, velocity is equal to the first derivative of the distance function. So let us find the derivative of s of t. Okay, that is going to be 3t squared minus 12t plus 9. So we found the velocity function. They are now asking us to find v of 2. What is the velocity after 2 seconds? So let's plug in t equals 2. I'm going to go ahead and evaluate this function. Okay, where's my calculator? Oh, she dropped it all the way down. All right, let me carefully go pick up my calculator without waking this little monster up. Okay, I got it. So let's type this in. 3 times 2 squared minus 12 times 2 plus 9. Guys, what did you get? I got negative. What does that mean? What does a negative sign mean? This is fun. Negative 3, and they didn't say the unit here, but I'll go ahead and say negative 3 units per second. The time is given in second. So if you're thinking of speed cannot be negative. If you're driving on a highway, speed has to be positive. If you're stopped, your speed is 0. But velocity can be negative because velocity is not only how fast you are going, it's about how fast are you going towards your destination. It has a direction. So guess what's happening? Here's my little fun particle. What are you doing? So a particle starts right here. And anytime this particle is going toward the direction, the velocity is positive. But if it's going back, because it can be doing that, it can be starting over here, it's like going to going toward that direction, and it's going backward. Anytime it's going backward, its velocity can be negative. Its velocity is negative. That's what's happening. Okay, so let me go ahead and erase this picture. What does the negative sign mean? That's a very good question. I'll go ahead and say this particle, this particle is moving backward. Okay, that's what's happening. Okay, all right, let's look at the next question. What is the velocity after 4 seconds? Oh, we already know the velocity function, which is just 3t squared minus 12t plus 9. So all I need to do is plug in 4. This one is easy one. What is this particle doing? Is it going forward or is it moving backward? It depends on the sign, right? Let me type this in. Look at this guy. This one came out to be positive 9 units per squared. Whatever the unit is, inches or meters or kilometers or miles, but it's moving 9 units per second at after 4 seconds. It's moving forward. It's moving toward a certain point that we're trying to get to. Okay, what about next? When is the particle at rest? What does that mean? Well, when is it not moving? So I'm going to say this is particle at rest. This is us trying to find at what second is the velocity 0. It's just not moving. So we have the velocity function to be, let me use a different color pen, 3t squared minus 12t plus 9. We're trying to find what t value will make this whole thing to be 0. Okay, so let's factor 3 out. Looks like all of these are divisible by 3. So I factored out the 3, because what I'm hoping is I don't want to use quadratic formula. Ugh, I just want to see if this is factorable. I think it is, because isn't 3 times 1 3? And if I make them both negative, they will add up to negative 4. So here we go, we solved it. At t equals 3 seconds and 3 seconds and 1 second, this particle will be at rest because its velocity is 0 at those 2 points. That was fun. Oh, now look at this one. When is the particle moving forward? I'll do it. Guys, you learned solving inequalities in Math 161, didn't you? So what we're doing is this. We're trying to find out when velocity is greater than 0, okay? That's when it is moving forward. What we know is that the velocity is 0 at point 1 and point 3. So what we need to do is we need to check these 3 intervals, to the right of 3, to the left of 1. By the way, it has to be greater than 0, and in between 1 and 3. So let's plug in some values in each of these intervals to check the sign, okay? So if I first start with the interval in between 0 and 1, what's a good number that I can plug in? Maybe I can plug in 0.5. I'll check v of 0.5. What will happen if I plug in half into this function? 3 times half minus 3 times half minus 1. And if you're wondering, hey, where are you plugging that into? I was going to plug it into the original, but I saw how we have a very nice factored form over here, okay? If I type this in, this is positive 3 times half minus 3 is negative, and half minus 1 is another negative. So this is a positive, right? Because positive times negative is positive. So velocity in between 0 and 1 is positive. So this is moving forward, because the velocity came out to be positive. Assuming that we don't know anything about multiplicity and the behavior at the x-axis, let's just go and, plug in the next number. I picked 2 because 2 is in between 1 and 3. Let's see the sign of this. 3 times 2 minus 3 times 2 minus 1. That is positive 3 times 2 minus 3 is negative. 1 minus 2 minus 1 is, this one is positive. Well, if you do this multiplication, I will get a negative answer, right? So what does that mean? That means the velocity is negative. This is moving backward. This is moving backward. Now I need to just check one more. Okay, the last interval, let me plug in a number that's greater than 3, maybe a 4. But didn't we find that above? Didn't we find v of 4 is 9 units? And 9 is positive. If you're wondering what? Here you go. We found it above. V of 4 is a positive 9. So that means our little particle is moving forward from 3 and on. And it never hits 0 again. It never rests again. So if it's not resting, it's just moving forward and on and on and on. So when is this particle moving forward? We have 2 intervals where it is moving forward. I will go ahead and write the answer using interval notation. From 0 to 1, this guy is moving forward. And 1 to positive infinity, given infinite amount of time, this guy is just keep on moving forward. From 1 and 3, this is just moving backward. This was a great problem where we had to think about, I used the inequality, polynomial inequality. Okay? Okay, so that was a good problem. E, find the total distance traveled in the first 5 seconds. Interesting. This is super interesting. Well, the distance function is given, right? The position of a particle is s of t equals t cubed minus 6t squared plus 9t. So I'm wondering, can we just go ahead and use this function? Like, can we just go ahead and plug in 5 in here? But you know, I just realized that we just kind of did this together, that this particle is moving forward and moving backward in these places. So I'm going to be a little more careful. Who knows, maybe I can just plug in t equals 5 into s of t, but I don't want to risk it. I want to do it the longer way. I think I'm going to use the fact that this is moving forward. So how about I do s of 1? I want to know the position of this particle at 1 second. Okay, so if let me go ahead and copy the function down here because it's way up there. I just want to copy it so that I don't have to scroll up every time I'm trying to use it. So I copy the formula down here. Okay, so this is the formula. So after 1 second, my little particle is located at all right, what's that? That is 1 minus 6 plus 9. My particle is located at 4 units, okay? So this guy went to the right, I'll say just right, went 4 units to the right. Now, in between 1 and 3 though, I want to find s of 3. Where is my little particle at time 3? That is 3 cubed minus 6 3 squared plus 9 times 3. That is, I'm typing this into my calculator. I'm trying to figure out where this little guy went. This is fun. Oh, look at that, 0 units. So the position of this little guy at time 3 is 0 units. So this is what's happening. So if this little one started right here, and there is 1, 2, 3, 4. So really fast, this guy, in the first second, he's like, uh-oh, I want to move this guy. Really fast, this guy, oh, you're my son. I want to grab this. I was able to move this last time. Let me try again. Okay. Ah! Okay, there you go, it's moving. So really fast, in the first second, it went to the 4. And it's hanging out right here. But in between second 1 and 3, he went backward to 0. That's what happened. Really fast, it went forward. And in the next, in between 1 second and 3 seconds, it went back to 0 units. Okay? All right. So what's the total distance covered so far? Well, 4 plus, because first it moved 4 to the right, didn't it? It went like 4 to the right at first. And then it went back another 4. It went back another 4. So I'm going to do 4 plus 4 so far. And then what? S to the S of 5. Where is this little thingy at 5 seconds? Let me plug it in. 5. Who is Steven Turner commenting on my video? 5 squared plus 9 times 5. Alright guys, let me plug it in. So this one is probably moved forward. 5 to the 3rd power minus 6 times 5 squared plus 9 times 5. When I plug in 5, I got 20 units. So at time 5, it just went on. Like it's like went all the way to 20. So I'm going to add another distance of 20. So the total distance traveled is 26 units. Okay? Because we had to still add the distance that it traveled to get back to 0 position, 0 units. So maybe I shouldn't have called it units when I did these. Okay, maybe I can just say at 4, and this one is at 0, and this one is at 20. Because they were just positioned, like maybe they are like a mile marker of a highway. So first, in the first 1 second, it went 4 miles. But in between 1 and 3, it went back to 0 mile marker. And then from 3 seconds to 5, it went 20 to the right. So the final answer is 4 plus 4 plus 20, 28 units. So final distance traveled in the first 5 seconds is actually 28 units. Next, find the acceleration at time t equals 1.5 seconds, 2 seconds, and 4 seconds. Now this one is way too easy for us, isn't it? Acceleration a of t is the derivative of the velocity, which means the second derivative of our original position function. So what is the velocity function so that we can just go from there? The velocity function was, let me copy this down here, okay? Copy. I'm coming down here. So looking at this velocity function, let's take the derivative of this. Okay, that is 6t minus 12. So if they want the acceleration at 1.5, I just need to plug in 6 times 1.5 minus 12. If they want the acceleration at 2, I'm doing 6 times 2 minus 12. Last one is a of 4. 6 times 4 minus 12. All right, let me get my calculator and start finding these accelerations. So in between one, that's going to be a negative. Oh, I don't know yet. I have to just plug it in. 1.5 minus 12. So the first one came out to be negative 3 units per second squared. Negative acceleration means this particle is, what's the opposite? My English is getting so bad, guys. Opposite of acceleration. Decelerate. It's slowing down, basically. This guy is slowing down, okay? Slowing down at 1.5 seconds. So next one, let me plug in the number. This is why I just make this one a extra example. 0 units per second squared. So acceleration is not positive nor negative. Okay, it's just maintaining that same velocity. That's what's happening right here. All right, 6 times 4 minus 12. That got me 12 units per second squared. So finally, it's accelerating. It's getting faster, okay? All right, when is this particle speeding up? When is it slowing down? Well, in order for me to answer this question, I need to set it up so that we know exactly when the acceleration is 0. Okay, and that 0 is going to be our boundary point. So let me do this. I'm going to go ahead and first find when is the acceleration equal to 0 so that I can find the boundary point. 6t minus 12 is equal to 0 when t is equal to 2. So at time 2, acceleration is 0. So what I will do is I will find the acceleration at time 4. Why did I pick 4? 4 is just bigger than 2, that's why. And which came out to be positive, right? That was a positive. So this is accelerating to the right of t. So this is speeding up because the sign was positive. Speeding up from after 2 seconds, really. After 2 seconds. Right, to find the acceleration before 2 seconds, I can just plug in a number that is smaller than 2. And I pick 1.5 because we already did it. And that one came out to be a negative number, right? So this is speeding down. In between 0 and 2, before 2. So what about the, will it make sense now? I'm just thinking, what about the acceleration at time 0? If you plug in 0 there. Well, I don't know. Okay, but that's it. I answered the question. So we are done. Speeding down before 2 seconds. I didn't want it to be like a 20-minute video for this, but I was having so much fun with this example. I hope you enjoyed it too, but I don't think I put something like this on your first exam, but I just found this online somewhere, and I thought it was a great example to talk about acceleration and velocities since we only did one example on it. But I'm going to go ahead and stop this video. Whew. Okay, I hope you enjoy this.